Hi, my name is Tejesh Achari and my roll number is 20951A04M0 and I'm from ECT section, and my topic is illustration of the role of continuous time unit delta signal in the generation of other signals. Discrete time views values of variables as occurring at distinct separate points in time or equivalently has been unchanged throughout each non-zero region of time period. That is, time is viewed as a discrete variable. Thus, a non-time variable jumps from one value to another as time moves from one time period to the next. This view of time corresponds to a digital clock that gives a fixed reading of 10:37 for a while and then jumps to a new fixed reading of 10:38, etc. In this framework, each variable of interest is measured once at each time period. The number of measurements between any two time periods is finite. Measurements are typically made at sequential integer values of the variable time. A discrete signal or discrete time signal is a time series consisting of a sequence of quantities. Unlike a continuous time signal, a discrete time signal is not for a function of a continuous argument. However, it may have been obtained by sampling from a continuous time signal. When a discrete time signal is obtained by sampling a sequence at uniformly spaced times, it has an associated sampling rate. Discrete time signals may have several origins, but can usually be classified into one of two groups. By acquiring values of an analog signal at constant or variable rate. This process is called sampling. By observing an inherently discrete time process, such as the weekly peak value of a particular economic indicator. So you have a graph showing that. So continuous time. In contrast, continuous time views variables as having a particular value for potentially only an infinitesimally short amount of time. Between any 2 points in time, there are an infinite number of other points in time. The variable time ranges over the entire real number line, or depending on the context, over some subset of it, such as the non-negative reals. Thus, time is viewed as a continuous variable. A continuous signal or a continuous time signal is a varying quantity signal whose domain, which is often time, is a continuum, example a connected interval of the reals. That is, the function's domain is an uncountable set. The function itself need not be continuous. To contrast, a discrete time signal has a countable domain, like the natural numbers. A signal of continuous amplitude and time is known as continuous time signal or an analog signal. This signal will have some value at every instant of time. The electric signals derived in proportion with the physical quantities such as temperature, pressure, sound, etc. are generally continuous signals. Other examples of continuous signals are sine wave, cosine wave, triangular wave, etc. The signal is defined over a domain which may or may not be finite. There is a functional mapping from the domain to the value of the signal. The continuity of the time variable in connection with the law of density of real numbers means that the signal value can be found at arbitrary point in time. A typical example of an infinite durational signal is display style ft sin t quat t in math bbr. A finite duration counterpart of the above signal could be the mentioned signal. The value of finite or infinite durational signal may or may not be finite. For example, and the displayed is a finite duration signal, but it takes an infinite value for display style t equals 0. In many disciplines, the convention is that a continuous signal must always have a finite value, which makes more sense in the case of physical signals. For some purposes, infinite singularities are acceptable as long as the single is integrable over any finite interval. For example, the display style t raise minus 1 signal is not integrable at infinity, but display style t to the power minus 2 is. Any analog signal is continuous by nature. Discrete time signals used in digital signal processing can be obtained by sampling and quantization of continuous signals. Continuous signal may also be defined over an independent variable other than time. Another very common independent variable is space and is particularly useful in image processing, where two space dimensions are used. Discrete time is often employed when empirical measurements are involved because normally it is only possible to measure variables sequentially. For example, while economic activity actually occurs continuously, there will be no movement when the economy is totally in a pause. It is only possible to measure economic activity discretely. For this reason, published data on, for example, gross domestic product show a sequence of quarterly values. When one attempts to empirically explain such variables in terms of other variables and or their own prior values, one uses time, series or regression methods in which variables are indexed with a subscript indicating the time period in which the observation occurred. For example, y might refer to the value of income observed in unspecified time period, t, y cube to the value of income observed in third time period, etc. Moreover, when a researcher attempts to develop a theory to explain what is observed in discrete time, often the theory itself is expressed in discrete time in order to facilitate the development of time series or regression model. On the other hand, it is often more mathematically tractable to construct theoretical models in continuous time, and often in areas such as physics, an exact description requires the use of continuous time. In a continuous time context, the value of variable y at an unspecified point in time is denoted as yt, or when the meaning is clear, simply as y. So here is a graphical depiction. A variable measured in discrete time can be plotted as a step function in which each time period is given a region on the horizontal axis of the same length as every other time period, and the measured variable is plotted as a height that stays constant through the region of time period. In this graphical technique, the graph appears as a sequence of horizontal steps. Alternatively, each time period can be viewed as a detached point in time, usually at an integer value on the horizontal axis, and the measured variable is plotted as height above the time axis point. In this technique, the graph appears as a set of dots. The values of variable measured in continuous time are plotted as a continuous function, since the domain of time is considered to be the entire real axis or at least some connected portion of it. So here are the graphs, all the required mentioned graphs. Thank you.